instead of variables, go ahead and punch it into your calculator again. All right? Or, like Mr. Colbeck has to do, he's got to try to figure it out. So today we're going to talk about negative exponents. Well, the first thing that we're going to tell you is the biggest rule about this, which is a big star. You can't have negative exponents in your answer. So do you understand what I'm saying by a negative exponent? It means just the exponent is negative. The answer again can be negative, but my exponent can't have a negative. So for instance, we can't have y to the negative third as our overall answer at the end. So we'll have to figure out a way to get rid of that negative. Okay, so yesterday we talked about subtracting, right? When we had this as our problem, we said that by rule that we introduced yesterday, whether it was multiplying or dividing, multiplying we would have added them together, dividing we would have subtracted them. So in this case right here, we would have always taken the top number minus the bottom number, meaning the exponents, sorry, not the numbers, and then we would have gotten y equals negative 2. And I told you yesterday that if you do it this way, your answer always starts off as being on top of your fraction. So we would have had y to the negative 2 over 1. But then I just got done telling you that we can't ever have negative exponents in my answer. So this right here, if this is how you would have given me the answer, this would be half wrong because you got to the negative in the exponent. Okay? Does that make sense what I'm trying to say there? So in a sense, when we went through this the other day, when we talked about simplifying instead of actually dividing, we said we were going to do what with this, these y's? We're going to look at it and try to take as many as we could from the top and on the bottom at the same time. So in this case, if I would take all of them on the top, I would take 2 away from the top, and on the bottom, if I take 2 away, what's left over? My answer would have been what? What's left on the top? Yeah, but if we're dividing, what's left on the top if I divide something by itself? 1, right? So here, this turns into 1 over y squared. So why did we get 2 different answers? Or what's the right answer? Well, by definition, if we can't have negative exponents, we probably would assume that this one over here is on, or is our right answer, but then it's totally different from what we had over here, right? So what do you think? How, or do you think those 2 things are the same thing? Anybody? Say yes? Addison's kind of thinking about it. Caleb's kind of thinking about it. Alright, so my rule is these 2, in a sense, are the same thing, but this one down here would be way better. This would be the unsimplified version of this. Because again, I never want to have negative exponents in my answer. So realistically, they are the same thing, but this is a way better answer because it eliminated the negatives. So, if, big star, if you have a negative exponent, you move it across the fraction bar and switch the sign of the exponent. And this is really important. This is where some people get caught up and start making mistakes. When we're talking about the negatives in these problems, we're only talking about the negatives of the exponent. We're not talking about negatives as negatives in general. That makes a big difference. Okay. So, as you saw over here, notice my fraction bar. If I have some kind of number or variable or whatever it is with an exponent, remember, every single time I can always make anything into a fraction by simply putting it over 1, right? So notice, if I would take my entire part that had the negative exponent and move it across the fraction bar, either from the top to the bottom or the bottom to the top, as you move it across, it changes it from a negative to a positive or vice versa. So realistically, I could have started down here and went up to this one, and as I take my positive exponent across the fraction bar again, it turns into a negative. But again, we would never want to go up. We always want to go down because we don't want this in our answer. Negative exponent.
What do you do if you have a negative exponent in your, like if you have a negative exponent with a number, what do you do with that then?
That's a great question. Holy cow, that's a good one. So, give me an example of what you're thinking of.
Like 3 and then like negative, like cubed, like negatively out.
Okay, so this is pretty good. I'm surprised you came up with this. That's really good. Way to go. So here's kind of the misconception. Is this what you were talking about? Mm-hmm. Okay. This is still not a negative number though, right? Would everybody agree? We're still having 4 to the negative third. So the only thing that's negative is my exponent in this case. So this can still go by the rule that we have. So we would turn this into what? Take it across your fraction bar, and this would turn into what? 1 over 4 cubed. Right? So I'm taking that whole thing again and moving it down to the bottom, but my exponent changed from negative to positive. And then I would go through and I would do my numbers again. What's 4 cubed? What's 4 times 4 times 4?
34.
So then this, I would simplify one more time into 1 over 64. Okay? Now, it's still different than this though. If I had this, as 2 different examples, okay? Now I have a negative x raised to the negative 4. So now I have both the number or base is negative, but so is my exponent. I don't care about the numbers being negative. I care about the exponents being negative. So when we make our exponents into positive exponents, we're still going to do the process that we just talked about. So we're going to move this to the bottom. And when we move it to the bottom, it becomes positive 4, like the other example, right? But my negative stays with the variable. So now it's 1 over negative x to the 4th. So the big negatives stay with the numbers, no matter if it's on the top or the bottom. Going across the fraction bar doesn't cancel out any negatives out in front. It only cancels them out in my exponents. And so realistically, if I had it on the bottom, 1 over k to the negative 6th, I can write this with a positive exponent by doing what? Moving it again across the fraction bar, and I would get k to the 6th over 1. So now, when you're doing these problems over here where you're reducing or simplifying using division, you can do it by doing the subtraction and always do the top exponent minus the bottom exponent. And even if I end up with a negative exponent, then I can switch it to a positive by moving it across that fraction bar. So again, now you can really concentrate on using the rules that we introduced yesterday if they didn't confuse you. Again, to me, it's just as simple for me to simplify by crossing the same amount out from the top as there are on the bottom as I would have done yesterday and still got my y squared on the bottom. But if you're a rules person or that kind of thing, You can go in and go back and do what we did yesterday. What do you think? Confusion? Yes? No? We had a lot of blank stares today. Yes, sir.
Can you make a positive exponent a negative?
You can, but we really don't want to. So, yes, I could take this, if this was my problem, I could just rearrange it again and move it across that fraction bar and make it into a negative, but I never want to have that as my answer anyway. But you could do that, absolutely. Okay? So, let's try some of these out. So if I have 3 to the negative 4th, is that what we already did? No. What do we get without using negative exponents? It turned into what?
1 over 3 to the 4th.
Perfect. But now, because it has numbers in it, we want to simplify again. So, what's 3 to the 4th?
81.
81. Perfect. So we get 1 over 81. Okay? How about this one? Negative u in parentheses to the negative 6th. What do you think my answer is? Getting rid of my negative exponents.
1 over negative 6.
Right. And here, do I need my parentheses? Is this different than this? Right? If it's an even number exponent, I definitely want to have parentheses. Because why again?
It makes it changes what you should really get.
Exactly right? Because we want this to be negative u, not just u to the 6th. Because if we leave out the parentheses, our calculator, and we use our calculator will do u to the 6th times negative 1, and then we'd actually get the opposite sign that we actually should get. So he's exactly right. Good job. Okay? Questions there? So some of the problems right here, they might say, can you, and I know they want you to basically, whoever asks, can I ever write them with negative exponents? Some people, or some of the problems, they actually ask you to do this. So if I looked at 1 over 125, can I write 125 using exponents? Can I break 125 into something that would use exponents? So in other words, could I take this right here and do the prime factorization of it and get something on the bottom that would include exponents? So can you do that or see that without doing the prime factorization? What? 5 to the 3rd problem. So if you can't see that, as Allison just did it, then you'd have to go through and do the prime factorization. So again, we would say what? What are the factors of 125? 5 times 25, and then 25 would get broken into. So this is 5 cubed, and that's what we already had. So if you can't see it right away, then you just do your prime factorization. But we're only looking at numbers that will be exactly the same, meaning we always want the same factors to be a part of the problem. So basically, and again, I don't know why they would really honestly tell you to do this, but if you would want to write this using negative exponents, what would we write for this? How would I take this and write it using negative exponents? This would end up being what? Yeah, because I'm moving it across that fraction bar again and taking it to the top. And again, if I wanted to write it over 1, I could, but I don't need that over 1. So again, they're going to ask you to do this just so you understand that you can do it both ways. But again, realistically, we would never want this as our answer anyway because we don't want negatives in our negative exponents in our answer. Again, we can't just say that we never want negatives because negatives are okay.